Hey everyone, this is Elad from Astrolab Diagnostics, and today I would like to speak about shrinking mass cytometry FCS files. And what do I mean by that? There has been a thread on the Cyto forum where one of the researchers was talking about how he manipulated a Cytof FCS file. I think it was with an R script, and the size of the file has shrinked by quite a bit, actually. And this is a known issue, and yet it can be quite alarming, especially for someone who is new to the Cytof, or let's say to an immunologist who doesn't usually use bioinformatics tools and is now using R to edit one of your files and sees that the file size shrinks. So to show you an example, I took a few files from the Frontiers in Immunology paper that we published with Mount Sinai earlier this year. And these are 4 files that were acquired using a Helios machine. And they haven't been debarcoded, they haven't been touched in any way. They just came from the machine, got normalized, and that's about it. And I am using the siteutils R package to rename the channels in the FCS file. And specifically, I'm not renaming anything. The siteutils package is using an Excel spreadsheet to decide how to rename the channels, and it's empty. So we're not renaming anything. We're just loading the files into R using the flowcore package, and then exporting them back, again using the flowcore package. And you'll notice that each of these files is about 1.5 gigabytes, and after the rename, they are about half a gigabyte. And specifically, if we choose one of them, we see that the size is 501,000 or so bytes. So what happened here? Where did 1 gigabyte of data go? And the first thing we can do is to make sure the data is still there. So I'm going to use FlowJo and open all the files, and we see that there's 1.8 million events in each one of them. And then let's start a new workspace in FlowJo. And actually, let's just open these files in the same workspace. Yes, let's open these files in the same workspace. Here they are. So now we have the original file and the file after using the R script, and we see they have the same number of events. So no data was lost. And just to be certain, let's have a quick look at CD3 versus CD19. So here's the first file, and here is the second file, look the same. And here's another one before the R script, and here it is after the R script. So again, data looks the same, no data has been lost. So what is happening here? Where did 1 gigabyte go? And to answer that question, we need to go to the data file standard for flow cytometry. And this is a document that was released by the International Society for Advancement of Cytometry quite a while ago. This doesn't seem to be dated, but I think it's more than 10 years ago. And you will notice that it has a long list of superstars in the field of flow cytometry. And this document explains what's in an FCS file, how an FCS file is structured, and how different packages can import the file, the metadata, and present it to the user. And specifically, when we scroll down the document, one of the things it's talking about is the header segment. And an FCS file is built of different segments. The header segment specifically tells us what's the other segments are about, what they have. So there's a header segment, and there's a text segment with some metadata. There's a data segment with the actual flow data or mass cytometry data, and then there's an optional analysis segment. And finally, there is an optional user-defined other segment. And this one follows the analysis segment, and user-defined segments are not interpretable by others unless whomever created them explains what's inside of them. So in order to understand what's going on with the other segment, we should open the FCS file with a hex editor. And a hex editor is a piece of software that lets you open files and examine their content in binary. So you can just see the raw binary data of the file and try to figure out what's going on there. And this is one of the FCS files I've shown you before the R script. And we can see the header. It starts with FCS 3.0 to explain the version and then the size of each one of the sections. So just so you remember, there's a data section, there's a text section, a data section, and an analysis section, and then the other section. And here are the definitions for the other section. It starts at this byte, and it ends at this byte. And if these numbers look familiar, that is because we can now go to the original FCS files and look at their sizes. So if we look at this file before using the R script on it, you will see that its size is 1503 and so on and so forth. Let's move this a bit so we have more room. This number is very similar, not identical, but very similar to the number we see here, which is the end of the other section. And then if we look at the file after the R script and look at the size, 501.176, very similar to this number, which is the beginning of the other section. So the difference between these two files is that the other section is missing, and we can further validate this by opening the new file after debar coding, and let me find it. After renaming the channels. So here is the file after renaming the channels, and you can see that the other section is gone. So the two numbers that signify the other section are gone. So again, the only difference between these two files is that the other section is missing. That other section can be quite big. It is introduced by the Fluidigm acquisition software. To be honest, I'm not exactly sure what that section is about. However, to the best of my knowledge, it should not affect any downstream analysis. Once you're done with normalizing your FCS file using the Fluidigm software, you really don't need that section anymore. So, first of all, if you do use an R script or Flojo or Matlab to manipulate your FCS file and the new file is significantly smaller, then that is usually not a reason for concern. This is just the other section that is no longer necessary and has been stripped down by whichever software you're using. The second thing to be aware of is that again, this should not really affect your downstream analysis. So yeah, make sure that nothing else is lost as part of your script, but you can still use the file and all is fine. If you are planning to store FCS files for a long period of time, then you might want to consider running them through the channel rename utility, and again, just blank the Excel spreadsheet and just move them through the utility, strip that section, and then store them just to save 66% of your storage space. So once again, I'm Elad from Astrolab Diagnostics, and quick sales pitch. We have an online platform for analyzing mass cytometry data, and if you need any help with bioinformatics, if you need any assistance crunching the numbers and getting meaningful biological insights from your data, please drop us an email. Thank you, and have a great day.